Moving on to chapter 22, shaping the Earth's surface. Right, so the primary thing here that we're going to be talking about is water. Of course, in different forms, liquid water and, of course, ice, including glaciers. Um, but also, towards the end, we'll talk about the wind as well, which contributes to the shape of the Earth's surface as well. All right. So these are the different topics we're going to cover. We'll start with the hydrologic cycle, so the water cycle basically. We'll turn to groundwater, what groundwater does, surface water like lakes and streams and rivers um, and then the drainage system. What happens, the deltas that form, for example, at the end of the base of a river, right before the river spills out into a large body of water like a bay or an ocean. The work of surface water, what the surface water does to the land, what glaciers and glaciation has done to the land, and is still doing, by the way. And of course the work of glaciers, and then the work of the air. All right, so let's start off. And this is something that every person on the planet should be well aware of. Or they, even if they're not, they need to become aware of this. 97% of the Earth's water supply is locked up in the ocean. Now it doesn't stay there permanently, but that's a huge amount, right? So most, that's by far the most water, is water that we can't drink. Think about that. Like we animals, plants can't. Most plants can't use this type of water. And so how is it that we get fresh water? All right, and where do we find fresh water? All right, so in the ice caps of the Earth, and of course the glaciers of the Earth account for about 2% of this is the overall water on the planet, and that of course is in the form of what we fresh water, and then of course groundwater. Groundwater is a little bit more than half. I'm sorry, 0.6% of the total amount of water on our planet. The surface water. So this is kind of a shocking. If you ever stood near the Mississippi River, it's a huge river, or you stood near the Great Lakes. They're gigantic bodies of surface water, but when you compare the water on the entire planet, it's only 0.009% of the total amount of water on our planet. So all that water, here in South Carolina, of course, you got Lake Hartwell, Lake Jocassee, and Kiowee. They're all connected, as a matter of fact, but still, it seems like a lot of water, but in comparison to what's inside of the oceans, it's really minuscule. And then the soil has moisture inside of it, and that's 0.005% of the overall water. All right, so let's look at this in a little bit more detail. So the hydrologic cycle, also known as the water cycle, that's a simpler way of saying it. That's what we're going to explore now. All right, so of course, remember, more than 97% of the water is in the oceans, and so we'll start there. And ultimately, the water has to end up back there, right? For it to be a true cycle, a true water cycle, the water will start in the oceans and then will end up in the oceans. Now, it could stay as glaciers for a long time. It could stay as lake water for a while. It could stay as underground water or river water, or even rain for a while, right? Or clouds. All right, so we start off with the evaporation, right? The evaporation process is going on constantly when the sun is shining over the oceans, and that's just about any given day. Some all over the planet. When we rotate, when the planet rotates towards the sun, you get sunlight, and of course there's evaporation taking place, and that's actually where that's turning the salt water into fresh water, but it's in vapor form, right? It can go and form clouds. Actually, there's another chapter that we're going to cover a little bit later on about clouds in particular, but we'll get there later. And so the heat from the sun is one of the driving forces of this water cycle, and then of course the gravity, right? Because when the clouds undergo precipitation, either snow or rain falls from the clouds. That is, of course, that's happening because of the direction anyway. Of course, has to do with the force of gravity. It all has to do with gravity, actually. Anyhow, that has to do with how high the clouds will go and things like that. But that's a different story. Now it's turned back into a liquid, and that of course is fresh water, and that fresh water, it could rain back right over the ocean, and the cycle is completed for that particular little parcel of water, or it could rain over the land. The water could freeze in the snow-capped mountains and could sit there for a while, right? I think that happens as well. And then let's say in the springtime or the summertime, the ice melts and it flows down. And of course, the other thing is when it rains, some of that water will seep down into the soil, right, and become groundwater as well. All right, so but eventually, over time, various times, the water will eventually go back into the ocean. All right, so there's actually a good picture of this in our textbook. Let's take a quick look at that. Let's see, do I have it? No, let's see, right here. Yeah, so this is really good. So when you think about some little partial of water, and how long it takes to complete the water cycle, that's called the resident time, right? So the resident time is how long does the water exist in the atmosphere, for example, and these are average values, right? So the water is evaporated, goes up into the atmosphere, and anywhere from 1 to 2 weeks, it will reside there, as clouds, and eventually it'll rain, right? The water in the oceans, in the shallow depths, so anywhere, relatively shallow depths, right? So you're not going down, for thousands of meters or whatever. That water exists there in the shallow depths of the ocean for anywhere from 100 to 150 years. Remember, these are average values, right? You just take a certain amount of water, maybe 100 meters underneath 100 or 200 meters underneath the surface of the ocean, and that little volume of water will stay there as shallow shallow water for about 100 to 150 years. All right, anyhow, the water in the very deep oceans can stay there for, the deepest parts of the oceans can stay there anywhere from 30 to 40,000 years, right? Water that ends up in the rivers will stay in the river for, and this is kind of a surprising thing when you think about it, anywhere from, so the same, in other words, the same molecules of water that are in the river will stay there for 2 to 3 weeks, right? And then, something else will happen, right? It could seep beneath the earth and become groundwater, or go fall into a lake, or the river leads to a lake or a pond. I mean, here we're not distinguishing between lakes and ponds. Or it could even go back into the ocean or something like that. Some rivers actually, like the Mississippi, right? It dumps out into the Caribbean, which is kind of is part of the oceans. All right. So anyhow, if water is in the lakes, like let's say Lake Jocassee or Lake Kiowee, or even Lake Hartwell, on average, that water will stay there for anywhere from 10 to 100 years. The shallow groundwater can be up to hundreds of years, right? So that's the groundwater that's not down too far. The stuff that's is much deeper can remain there for thousands of years, and then we get to glaciers, right? So glacier, the water that's locked up into glaciers can be there for anywhere from 10 to 20,000 years. Right. Let's switch back to this. Okay, so this is back to our PowerPoint slides. Let's make that larger. All right, there we go. So that's I like that table because it kind of gives us a better sense of the amount of time that goes on. All right, so this is what we were just talking about, the evaporation. Precipitation, of course, is either snow or rain. This infiltration is when the water seeps below the ground, and then runoff is when it either there's a flood or it just naturally follows the river down into the ocean or a big bay or something like that. All right, let's see. So water goes from the oceans back to the ocean to make up a complete cycle. I mentioned that already. The journey is not always direct. The water can flow as streams or rivers or groundwater. It can be ice caps. It can be glaciers, and as we just saw in that table, whatever table that was from our textbook, that these can vary greatly in the amount of time. Right, that amount, that certain water in a certain glacier, on average, will stay there. All right. So the Earth's natural supply of fresh water comes from, where do we normally get it? Mostly rain and snow. I mean, these other ones do have fresh waters, but the natural supply that we come across on a daily basis is the rain and the snow. All right. Okay. Let's see. So, let's see. Moving on. All right. So next, we talk about the porosity. Okay. So factors that influence the storage and the movement of groundwater. Okay. So now we're turning to groundwater. We're going to spend a little bit of time talking about groundwater. So let's define this in the last half minute. Porosity is the ratio of the open space in the soil to the volume of the soil, and plus the voids and so forth. So with the openings, basically the greater this porosity, the greater the water can flow.